All right, here we go. Welcome to class 7 of the live stairways and the stairway to DAX and Power BI series. Sorry, I'm just getting going here because we're having a little trouble with the demo content, but that's all right. I've been hoping somebody would respond. This is a live stairways where we're working through this stairway looking at DAX and Power BI. Now the first, I believe, let's call it 9 or 10 levels dealt with Power Pivot, working with Power Pivot in Excel, even though we've been using Power BI. And then the last time we actually got into Power BI, so I believe it was either Max or in product that we actually got into Power BI. So for class 7 today, we're going to look at Concatenate and Concatenate X in level 11. And we'll look at level 12 with Count A and Count AX, which is a whole different area of things. So let's get started looking at DAX and Concatenate. Now, again, as we've learned in the last few levels, there are these aggregate functions or these, I don't know what to call them, normal functions. They're functions that operate on the entire table. And so that would be concatenate, count, sum, average, etc. And then there are these X functions that have an X response to, or an X appended to the end of the function. And these work row by row across the entire expression or table, right? It's still a table, but you can use an expression, a filter, or something in there to get a limited number of things. So as we go through here, we'll look at concatenate, which seems like a silly function to me, but it is what it is. Now, we're still using the Contoso sales sample for Power BI desktop. You can download this from Microsoft, and if you click this, you actually go to the direct download. You can see it's just pulled down. I've actually opened this up already here in the Power BI desktop. You can see that we've had some of the things we did last time. I'm actually going to create a new page, and this, we'll call this Concatenate. And we'll use that for our reporting. The first part of this article is an orientation of Power BI. I think we've done some of this. I'm going to skip this part of it. We're going to go to Concatenate. We haven't looked at relationships. Maybe I should spend a moment there. We've been mostly working the report with this data model area where I can choose the different tables that are in my data model. But there is this relationships tab, that allows me to better understand how things are related together. And because there is a related function in Power BI that allows me to kind of link items together and have the slicers dynamic changing of the reports in the first report tab, I think it's good to be able to look at this and understand where things might be changing and understand what's happening. So you see here that product subcategory is related to, well, product subcategory key, right? And both sides, it's the item that's linked there. Here we have the product category key, et cetera, et cetera. So Power BI does make it easy and helpful when you're trying to understand how my data is related and how I might put it into a report. So let's look at concatenate. Now concatenate is part of the text functions group. So it's not an aggregate, but it's designed to put values together. And so it does what you think it would do, is it concatenates two text strings together, but only two, only accepts two arguments. There is an operator, which is used to join multiple items. And honestly, I don't know why we would use this function, as we'll see later, but it joins things together. I do see that there's value sometimes in having this function available because it gives you additional functionality for things like labels and headers and that kinds of things. So the syntax is two text strings passed in as parameters. So there's a simple literal here. We could actually do this in the item. So if we say we've got a, what did they use these? Oh, he's just doing simple text. Let's create a new column just using concatenate. So I'm going to call this silly example equals concatenate, and we'll say simple, and we'll do a space there, text. Now when I do that, my silly example column now says simple text, which is insane to me. It's crazy. I said simple function and change that. That's what I'd get. So I assume this might be useful in annotation. I think it's probably better in a measure than a column, but it is what it is right here. So that's what we expect. And now there's a promotion item. He's got this concatenate thing, which I think is absolutely crazy to try to make this a function. So if I said, let's go to promotion here, and we'll say new column again. And then we'll say silly promotion equals concatenate. So in this case, what I want to do is I'm going to do the, well, we'll do another one. We'll do concatenate again. In this case, we'll say that it's the promotion label. And then we'll say a dash. And then that closes the inner concatenate out. And then the second one, we'll actually do the promotion name. Close this out, which is what Bill's example is. And you can see here now that what I'll actually get is this label and this promotion name put together. But this, to me, the structure is incredibly difficult to understand because I'm trying to look for a parameter here, and then say this result is a parameter here. To me, it's much, much easier if I were to ignore this concatenate and I were to change this to work with the concatenate operator. Close out those parents. This is much simpler to read, and in fact, this should result in the same sort of thing that I expect, which I've got the label here, and then I've got the name there. And to me, I find this much, much easier to read as a developer, somebody that's actually working with this. But it's 6 of one, half dozen of another, I guess. Less useful to me, but we'll see. Now we go to concatenate x. And concatenate x, again, the x function that is an iterator, so it moves across rows. We've seen this with our sum, average, count, etc., where we've used a table expression, often with filter as the first parameter, which would be the syntax we see here, concatenate x. We have an expression that we would use that operates across each row. So in this case, we would return some value there. And then there's a delimiter as a third function, which we haven't seen in the other x functions. So since this is a text group function, this makes sense that this is going to actually give us some way to delimit things. So as a quick example, in the product list, there's a very limited list of items. And so if we look at product list, do we not have product list? Product category, sorry. We do have a very list, 8 items in total there. And so the concatenate x is saying take the product category, which is that table, and we'll return the product category field or column with a comma delimiter. And what we do is we get a list of columns. Now that's annoying. I don't know why I would use this. I think this is a poor example, but we'll give it a try. So in the practice area, we're going to recreate the count of the promotion items. So we're going to create a new column here, and what we're going to do is that concatenate. Now we did that in the promotion area, so we see that here. And we've tried it this way, and we've tried it with the and. And matter of fact, the example Bill has here is promotion life is a new column here. I didn't get all of that, but promotion life is going to concatenate 2 date columns instead of 2 text columns. He does mention that in Excel, this is as a number of arguments. In Power BI, it's only 2 for some crazy reason. But let's use this example here. So now I'm looking at the start date, which would be here, and the end date there. I'm putting those together with the concatenate operator, again, instead of the concatenate function, which I think makes perfect sense for trying to build reports that might have complex text manipulation or more than 2 text items that I'm trying to put together. In this case, I assume this is some implicit conversion that's making this text as opposed to being a date column there. So we see that there. I think, as Bill says, it is scripting is easier, and I completely agree. I don't know why I would use the concatenate function anywhere, honestly. So let's put this together in a report view now. So in the report view, he's actually going to use a card, which I don't use too often when I've experimented, but a card is here. And then I assume we're going to put this silly promotion thing in there. Is that what we're doing? Oh, now we're going to create a measure to use. That's good. It's probably something that I'm missing here. So pulling the card, and we want to create a new measure from product category. So product category, let's close these down so we can see it. I'm actually going to move visualizations and make this slightly easier to use. New measure. We've got it there. And what we want to say is we're going to concatenate X. So we're going to take the product category table. So we're taking the full table. We're not filtering here. And then we're going to grab that name product category column or that string column with a comma delimiter there. And so if I expand this and make it slightly larger, product category table for product category column with a comma there. So I get this new measure. If I drop that over there, I see it. Not terribly useful and certainly hard to read. I do believe with this visualization though, I can word wrap it. So that maybe is more helpful. I don't know that I think this is a great example. In this, with product category list, can I put a space here? Will it respect a 2-character delimiter? It does. So I get a space in here. So that's interesting. Some of those, certainly in the SQL area, sometimes a delimiter or that parameter is only a single character is allowed. So this time we want a simple text list for the brand name that are offered within 3 product classes. So there's brands and classes. And in our model, let's go back to the model because it's easier to see. We've got these channels here, and then the class name in the product table. So we've got class name. These are all economy regular. So it looks like there are just a few values repeated over and over and over again. So they want to use a slicer here, which is one of those areas I think makes sense. When I have a text column, sometimes I want to actually have a slicer that filters that down with data and everything else that I've got in there. So Bill says a blank canvas. I'm actually just going to reuse this one because I think this example is incredibly silly. So we're going to add an empty card, and we're going to do a new measure for product here. So let's do a new measure for product first. And the product is going to be class vendors, concatenate X values, product brand name. So let's put this, let's make this bigger. We'll put that in there. Now, when I was doing the prep and the homework for this and I read through this article the first time, one thing that stuck out for me is that this values function is not explained in this area. So I actually searched and looked it up just by going DAX values function. And what this does is it's essentially a distinct from a column. So duplicate values are removed, only unique values are returned. So what I think we're trying to do here is find just the limited brand names here out of product, of which there are few. And then we're using that filtered table expression, which should only be a few values. And we're returning from that the brand names themselves, the distinct ones, with a space comma space separator. So that's our measure. And we'll stick a cod back on here. New measure, so class vendors. So the card is selected. Our measure comes in there, and we see these class vendors, the brands, I assume. And then, as I did before, I'm going to turn on word wrap so that we can see this. So these are in the brand name column. I'm trying to check my wording there. In the brand name column, there are distinct values. There are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 10 distinct values. I wish I could make sure these didn't break on spaces, but in any case, these are the class vendors from the measure we've created, which is a distinct list of the brand name column. And then we're using Concatenate to essentially make one long string here, which, again, I'm sure somebody needs this in a report. I don't do enough of these financial reports for people that somebody probably wants that. All right, so we're enumerating this, and now we're going to do a slicer. So a slicer, that was the wrong thing. Let's do, okay. Always remember to click into a blank spot if you want a new visual. So for a slicer, what we want to do is do the class name. So let's drag that over there. And so we see, we get a unique view of these already. If I said deluxe, something disappeared. Said economy, looks like everybody's there. So deluxe takes out Northwind, and maybe that's it. Prosware, no, they're all there. So Northwind comes out because it's not, apparently not a deluxe brand, but in economy, nothing changes. Not a great example here because there isn't enough change there for what's going on. All right, that's it for this level. And honestly, probably all this deserves. I still don't have a great feeling for where this concatenate thing makes more sense. I mean, I think more often when I've built reports, what we really want is some sort of list or drop down or view of items that are there rather than this as kind of this label, but it is what it is. All right, let's move on. So in this next level, level 12, we have the count A and count AX functions. In reading through this, it's slightly confusing because I haven't encountered, or at least we don't have a good feel in the data model of how I get a column that has multiple different values. I assume that sometimes there's a column that's a text column that somehow has numeric values and we're counting those, or we're summing, aggregating something, or there's blanks. But this is saying that we're using kind of count in places where we, how do I say this? Where we've got mixed data types, not numeric or not date, and we want to actually count them up. Confusing, but that's kind of what I got out of it. Again, count A is the general function that takes just the table, and then count AX is the iterator that works across there. So now we have count X, count A, and count AX functions that we'll have gone through by the end of this. All right, there's some opening here. The preparation is to get this sales management demo file. This GitHub repo does not exist. And I put out a note to somebody yesterday. I didn't hear back. I put out a few notes today to people at Microsoft trying to understand what happened. Apparently, this repo has migrated and moved somewhere. I cannot find this PBIX file as of now. So, one hand, that's good. I don't know when this happened. I assumed in 2017 this was working because there's an editor's note here. But for now, it's not there. So the examples that we follow through in here will have to be on a different data model because This data model with these sales and channel and stuff is slightly different. As a matter of fact, this is the Contoso view because that's there, but there's a users table in the sales manager demo that I do not see here. So I think that's a poor image. I bet you Bill just repeated this. No, that says user there. But in the Contoso item, we obviously do not have a user table here at all. I'll shrink these up. So one of the things I did decide to do because of the way that he's giving these examples is I thought to just create a quick table. So I created a table here that has some different values. And if I look at this, you'll see that there's some dropouts in here in places. So this actually would have 4, 5, and 3 that we could go through there. And I assume that I can kind of use those in going through these examples. So we'll try it and see. Hopefully somebody at Microsoft will let me know where that repo migrated to, and I'll fix the article so it's there. So DAX count A counts the number of cells in a column that are not empty, counting not just rows that contain numeric values, but also rows that contain non-blank values, including text, date, and logical values. Again, I don't know how I get all these different values into one column. I haven't found that out yet, but maybe there's a way. This is an aggregate, so like count, it's an aggregate, but it's not operating on just dates or numbers. It's operating on text values or logical values. Bill gives us this explanation here that the A functions employ only a single parameter, unlike the X functions. But the count function, if I remember correctly, only implies a single parameter as well. Matter of fact, let's pop count open here. So where's count? Count function, a single parameter here. So the A, I assume, just means all or any, something like that, counting all different data types. Yeah, okay, so that's what he says. It differs from the base function here. I thought I had read that in here before. So we'll give it a column from there and we'll get back the count. So here he's saying count of this table column org level 4. So I assume that means something. So let's actually create a user table. So that's not too, I'm just make it user sample so that's easy. And let's create this to be user because that's really simple. And then actually I probably should just, let's go ahead and replace all these with user. See what we get. So user sample, username. I don't really care about not null here. User level 1, 2, 3, 4. User A, B. Let's play a cat with org. That matches up better. And actually, let's change these to orgus too. If we run this, that won't work because I don't know how to edit SQL very well. Since I did create this, do a drop. That's how I build samples often than I would like. All right, so now again, I've got 3 org levels and 3 product levels in my database. So let's add those to our file because I think that will help in some sense trying to follow the examples in there. So I'll connect to my SQL Server, and this is SQL 2017 is the one I'm using, and I'm using the Sandbox database. Hopefully that is correct. And once this pops up, we'll pick that product sample and that user sample table, and we'll load those in. So don't forget, this isn't a live connection to SQL Server. This is in fact a query against SQL Server and then pulling that data back into my Power BI report. So my PBX file, it's a zip file really, will contain these data models. So there's my user sample and my product sample. So in this one, this is the discussion, the syntax, count A with a column in there, which we'll do. Count AX is the iterator. So it counts non-blank results when evaluating the expression over a table. So matching count A, it's going to do not just numeric or date fields, but also string things, and it returns on empty. Now there was one super interesting thing here. Count AX counts the cells that have any type of information, including expressions. So if the column has an expression that evaluates to an empty string, it treats the result as non-blank, which seems insane to me. I do find at times when Excel is copying over formulas and not the values there, I get some strange behavior as well. But I don't know what to say. One thing, I think this is something you got to keep in mind. If you're building a count on an expression that returns a blank, it's going to get counted as a value there. It's a non-blank value, which seems weird. Okay. Alternatively, if there are no rows in your expression, it returns a blank. And if rows are found but none meet our criteria, it returns a 0. Okay? We've kind of seen that with the other iterator functions as well. So the syntax here is the table and then the expression. So in this case, the table is a filter that Bill is using here. So he's filtering on the count country is equal to some value. We'll obviously have to use some different thing here when we do this. And then he's returning a city value, and then he's getting a count. And so the purpose in here is he's looking at Sri Lanka, saying that there are city values in for many accounts, but some places there's a country value, but there's no city value because it's a national account. So I've seen this type of view before, and I'm just zooming in, where I'll have some data field, right, like country, and then we'll have some other field like city. Often I think this might be like there's a region, there's a country, and then there might be a sales rep. And so there's times where a sales rep has a region and a country, but maybe he has the entire region or she has the entire region. So there's no country listed. So there's a dropout in there. So count AX, let me make this more readable again, is kind of a neat way to get the list of those that are specifically set to a sales rep, for example, but not those that are national sales reps. So the people that are kind of outside of that. And I can see us using this at Redgate because we have sales reps that have regions or products areas or different things, but then we have these large account people that would kind of fall out of that data set because they wouldn't be in this extra column that we might have. All right, so Bill is saying he wants to look at org level 4. We don't have a 4, but we'll do 3. So we'll pick this and we'll make a new column and we'll say count A there. So user sample, I'm going to say a new column. And does he give it some kind of number? Level 3 is equal to count A. And we'll say it is the org level 3. So based on what we've read, it should be 4, right? 1, 2, 3, 4. These are blanks. Let's see what we get. We get 6. 6 is not helpful. These should be blanks. Why would I get 6? There are 6 rows. It did say count A, org level 3. Like values. 4, 5, 6, 7, 8, 9, 10, 11. So he gets 11. I don't. Interesting. I wonder if there's some data model thing what if I said, I'm sure this is still going to say 6, but interesting. Why would that be different? Because I did insert blanks there, blank strings. Could it be for nulls? Let's try to refresh the data. So if I were to insert in here, let's say user G here. In this case, the data refresh. So I have a G. Getting a 7 there, but what if I change this back to a 3? 6. Aha. So the null value here, which appears as a blank, is different than the empty string value there. I think that's a piece of research I'll have to actually look at and say, why am I getting a null value not counted, but an empty value or a blank string counted? Very strange. So he's doing it in the products as well. I assume I'm going to get the same kind of weird value there, but I'm going to skip this and move on because I clearly don't understand something about how the data model is impacting this function. I would assume that there should be a 4 there. It says 8 blank rows. Sorry, there's a fly here of some sort. Not appearing there. In our data model, I wonder, I thought that there was a table that I saw where I had some blank values. In one of the columns. I mean, I think for most of us working with data, when we find blank values, it's incredibly annoying because we expect there to be data in most of those places. Here, store. So store in closed reason, there are only a few items there. 12. So let's try to create a new column here. So we'll say number close reason, count A, and we'll say this is the close reason. So there are obviously lots of rows in this table. Do we get our 11, 12? Nope, I get 306, which I'm assuming is the number of rows in this column. No, it's not. Well, maybe it is. No, it is 306 rows. So why are these not captured? Fascinating. I suspect it's a null thing, that there must be some sort of null, and that's different than a blank string. I don't have a good reason to tell that. Well, there we go. Something else we've learned. Now, in terms of creating a measure, I just assume that my measure is going to use concatenate x. Sorry, count AX, not concatenate x. Count AX here. So we're going to create a card, and we're going to use a new measure that says we're looking for the name, count name here. Do we have anything similar to that? Well, let's try it with our product thing, with our sample. So let's create a new table, and we're going to rename this to count AX. We're going to put a card in here. Now, I'm going to do product sample. I'm going to create a new measure. And got a number of accounts. Product 3 is equal to count AX. I'm going to give it the whole table. So product sample. And then what we're going to do is count the product level 3 items. I think we'll just stop there. That's all they've done in the sample in the article. And so when we say this, we've created this measure. Let's put it in there, and it says 6. Now we know it's not 6. Well, we do know it is 6 from the data model because refresh my cache here. Two, three, four, five, 6 items in product here, of which 4 are non-blank. And apparently all of them are being counted here. That is really annoying and upsetting. In any case, don't know what that really means. So he's doing a matrix, looking at all the accounts. I wonder what happens if we do put a matrix in there. So we'll do a matrix, and we'll drag over product sample. Do I have to do everything? I just want to do product name, numbers. Number of accounts by country, some total. I don't know. I don't have a good data model that matches this up really here. But for each one of these, product A, B, C, D, E, F, we have one of each, product A, B, C, D, E, F, and we get 6. So I get 6 as the total count, which is what's there. But level 3 isn't there. If I were to say, yeah, there's nothing that matrix is out there because I've changed this. Crazy, 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 crazy. All right, so this gives us a reality check of our calculation. I don't know that I think that that's true, but I'm going to have to do some more research, and I'm probably going to ask some questions to people why count A and count AX are actually returning to me 6 instead of 4 or whatever value I have that would match up. So we'll see. We'll see. I'll post something in a discussion for this level, and we can see. So that gets us through most of the levels here. I'm just going to go back to the parent. So we've now moved through 12, count A, count AX. Next time we do all, and I think I've got some apprehension about starting this right now because I do think that all is slightly more complex. I've watched some people present on this a few times, and it's been a little confusing why this breaks away from kind of the filtering and linkage there is in other things. This does use, and I think I want to check this Power BI demo file, which is a 404. So I'm going to have to try to track that down or try to rebuild some sort of data model that's more useful. But in class 8, we will get through level 13, and then we will stop there, assuming that Bill doesn't get me level 14 before we finish. So hopefully you found this interesting, and you've got some idea of why or how Concatenate works. If you don't have any idea of why the count A and count AX functions aren't working as in the article, I'm right there with you. I don't understand either, but we'll figure it out and we'll post something. So thank you very much for joining. Hopefully you found this interesting. If you want to check out the other classes we've got, they're on the hub and the community circle. And then the classes are under the data platform classes area. And you'll see this one listed there, and you can look through all the other items. At some point, these will probably be on Redgate University, and then you can find them there. So thanks for joining, and have a great day.